So hello everyone, I'm Yashovardhan Katika. Today I'll be presenting on a topic of planning and task decomposition strategies in the agentic AI systems. In simpler terms, we'll understand how AI agent don't act in a complex way that actually plans before acting on taking actions on any particular task, like how humans do break down a particular task into multiple subplans and they'll execute. So most importantly, why we should know why these agents fail most of the times when we give the prompt. Hmm. So agentic AI systems must plan before acting. So without planning, agents may fail. They may interrupt with the different anomalies, and they may take the wrong actions and waste the resources like tokens and etc. So we can so for the example, if I can tell you, when we build any website, you start coding randomly, but you will get stuck very quickly, like to develop something. So that so same kind of problem the agentic AI also faces if if there is no proper planning while we are structuring our task. So planning plays a very important key role here to manage a particular task and achieve the milestones in that project. So let's go to the next slide. So why planning matters a lot in agentic AIs. To solve a complex task, we need more interesting error handling situations um, and throwbacks. So these will help the agent to track back the actual problems that are inside the um, project, and they will be able to mitigate them in a for long term in a proper way. So task decomposition. So task decomposition is one of the powerful concepts in the agentic AIs. This is where the big tasks are broken down into a smaller subtasks, and they will be processed according to their what we can say. It's a kind of um, tokenization or the ease of task. uh, so like that it will be segregating. uh, for example, when we build any kind of a website, we will be first asking an AI agent. So it will break down the task into multiple ways, like designing of UI, building of front end, creating backend APIs, connecting the databases, and deployment activities. So now each step is clear and manageable. So even you have a very clear cut vision on what is going to happen in a process. So this will help the user and also the organization to keep track of things in a particular project, like what's happening at what time. Apart from that, there are two comparisons that happens in this particular thing, that is chain of thought versus tree of thought. So first, chain of thought, this is a simple one where one step leads to another. A single path for a reasoning, example, when we solve any kind of a math problem step by step in a one direction, then it may achieve the solution in a particular amount of time. But here in the tree of thought method or methodology, there is a advanced reasoning methods, and there are multiple paths that can be explored. So with this, the agent in in its MCPs and the background have this kind of tree of thought methodology. So which an AI agent can think to solve a problem in multiple ways. For example, when we are trying to resolve any coding problem, first we will try to analyze what kind of methodology can be used, like such as hash mapping or brute force methods, etc. So then we can able to optimize the logic according to the approach that we are following, and then we will use the data structures and algorithms that are suitable for that particular solution fix. So the agent explores all these best parts from its available approaches, and it will give a better output within a better accuracy. And how the planning algorithm works. So now let's go deeper and let's dive into the planning algorithms. First, the hierarchical planning. When a hierarchical planning is nothing but when a big problem or a big goal is divided into a smaller goals, and the actions will be taken according to that. So let's assume while building an application, uh, there are several steps we have discussed about, like designing of UI, backend, database setup, etc. So these type of reasonings are the common reasonings, but there comes a BFS style reasoning, where it explores all the levels of the reasoning step by step, level by level. And if the agent is able to find a solution in a very prior steps, yet it will also explore the other prior steps to analyze the which step is mm, more better to find a solution. This prevents the bad decisions. So whenever there are any multiple ways that we can solve a problem, it will choose the best way, and it will analyze which could be the better option for a long term. So these algorithms make agents behave more like an engineers, not just a guessers. Dynamic replanning. Now here there are no so here the agent adapts when things getting failed. So this means they dynamically replan everything that they have failed for. It means the agent detects the failures. It will change the plan according to the errors that it has got, and it will find new approaches that could be possible. That could be possible. The agent tries to fetch the data, like for example, the agent tries to fetch the data from the API. Okay, so it may fail, but it will not stop at that point. It will try to figure it out, like what is the reason for this particular failing of the API fetching, and it will switches the plan by analyzing the whole structure properly, and it will change the plan according to its feasibility. This is a real world example to discuss how the planning works. A well planned agent will do a step by step process, as shown in here, where it will understand the requirements first, and it will design a proper prototype or a UI to understand the mechanism, it will also help us to develop the front end work, and the backend APIs, and it will also test the APIs by its own test cases. For example, by running the PyTest cases, and it also can deploy onto the staging or production servers easily without any problem. So, with this clean and structured approach, the agents can basically behave like an intelligent systems, and they can perform the outrageous out the task in an outrage manner. So conclusion for this particular presentation is like the planning is not just an optional; it is just a foundation of the intelligent systems. We learned that decomposition simplifies the complexity, where reasoning and strategies will improve the decision making of the agent. Planning algorithms will help the agent to perform the better executions, and dynamic replanning ensures the adaptability that an AI agent can follow. And the final thought of this particular presentation is that an agent is not just an intelligent because it acts with a different agents. It is intelligent because it knows how to plan the particular situation, and it will execute according to that particular plan in a structured manner. So by this, the errors in the project or any kind of mitigations that are happening in the project will be less, and the accuracy of the project will be enhanced. Thank you.